Hi, so this is our quadratics unit, and this is lesson 12.5, and this is about radical and their rules. So here are a couple of notes I'd love for you to try to review these, and you can even write them down if you're just writing on a notebook, but I will have you rewrite some of the rules when we get to those graphic organizers that I will model filling out in just a minute. But to wrap your head around the big idea, radical rules. When we simplify radicals, so simplify is different from solve. So it's really important to distinguish between those two words. So when we simplify radicals, we use two rules. We use the product rule, where the square root of a times b equals the square root of a times the square root of b. So if we look at an example there, I have the square root of 36. Well, I could break down the square root of 36 into some factors, right? And the factors of square root of 9 times the square root of 4. So if I think about 9 times 4, I can easily take those square roots and I can break those apart. And the root of 9, square root of 9 is 3 times the square root of 2 is 6. Okay. So then there's a quotient rule too. So if I have a square root of, say, a fraction or a over b, I could break that apart into the square root of a over the square root of b. And if you continue on, I see an example like a square root of 4 over 9 equals the square root of 4 over the square root of 9. And so I could simplify that to 2/3. Now, notice this is important. If you're being asked to simplify, you're assuming that you're looking for the positive or the principal root. So principal means positive. PP stands for P, right? Positive. And then if you are really focusing on solving, so if you have a quadratic equation where you have to solve what's under the radical sign or what's in the radicand position, you are looking for the positive and negative roots though. So just keep that in mind, okay? Now I'm going to move on to our lesson. Sorry, it's going to be a little funky as I transition. Okay, so now here is unit 5, 12.5, and now we're going to fill out some notes together, keeping that little mini lesson in mind. Okay, so if I start to just label and identify some key parts to radicals, like let's go for it. So if I look at the nth root of a number, a can be written as this type of expression. So if you see in this underneath this radical sign, it looks like a check mark, by the way, the radical sign, and then there's this kind of this line on top, and that's where it came in. This is actually called a viculum. This is like a check mark. But anyway, you don't need to know any of that right now. But what I do want you to know is that n is called the index. What we are doing, though, in our quadratic unit, you're going to see that the index is really, it's always going to be a 2, because we're always trying to find a square root of numbers, because these are quadratics, or these are variables that are squared. So when we simplify or even solve, we are looking for the square root, and square roots when we are solving are always going to be the positive and negative values that when you square them equal the squared number. Okay. This sign, again, is called a radical sign. And whatever is underneath the radical sign, this is called a radicand. And when we learned about long division, we had that division sign, and what was underneath the division sign was the dividend. So it's pretty related, but kind of the same word ending. If there is no index, so if this is blank, it is always assumed that n is 2, or that you're just finding the square root, okay? If in doubt, find the square root. Okay, if a radical has more than one root, the radical sign indicates the principal or positive is what we're looking for when you're simplifying. okay? Now, when we are working in the world of radicals, it's really helpful to know your perfect squares. So I'm going to list the first 20, actually, square numbers. And you can test yourself right now. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. So these are the first 10 squares, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that are squared. So those are the first perfect square numbers from 1 to 10. And now I'm going to do the next 10 perfect square numbers. So now I'm going to have 121, 144, 169, 196. I always remember that. 169, 196. 225, 256, 289. I'm going to run out of room. 324. 1, 2, 3, 4, 5, 6, 7, 8. I need 361 and 400. So again, 400 is going to be, think about what that is a square, what its square root is, right? I've got 20 times 20. Okay. So down here, perfect square roots. This should come somewhat easily. So remember, there's no index, so it's just going to be a perfect square number. So that equals 4. And again, if we're just looking for, please hold on. Thank you. Here we would say 2, and what we say, by the way, is 2 root 121. Okay. So this means that you're multiplying 2 times the root of 121. So I can break this down to 2 times, well, what is the square root of 121? It's 11. So I'm going to end up with 22. Hold on. I'm in the middle.
What would you like for a sandwich?
Oh, don't worry about me.
Would you like a sandwich?
Don't worry about me. I'm trying to finish a video here, okay? Thanks, sweetie. I appreciate you. So here I have 6 root 289. So again, there are different ways I can say this. I can also say, so again, I could say 6 root 289. I could say 2 radical 289, and I could also say 6 289 squared. So lots of different ways to say this. But if I look at 289, what I want to do is I want to break 289 into its parts. That, well, let's see, is 289 a square number? Well, I think I remember writing it. And if I had more room here, I would show you that this is 17 squared. Shame on me for not really writing it out better. But what can you do? You can always look up online, and it's handy to actually have a list of those square numbers. Anyway, going back to this. So I'm going to say this is 6 times the square root of 289. 289 is a perfect square, and its square root is 17. Okay, so I would then multiply these out. 6 times 17 is 102. Okay. 3 root 400. Okay, so that means 3 times square root of 400 is 20. 3 times 20 is 60. Okay, so down here, I have some tips for how to simplify these non-perfect square roots. So you're going to see a lot in quadratics that you're going to see numbers under the radical sign or as playing the role of the discriminant that are not perfect squares. So what we want to do to break those apart and try to simplify them is we're going to factor these numbers out. So find the largest perfect square. So after you factored it out, that might itself be a perfect square. And then we're going to break down the radical. Okay, then we're going to take the square root of the perfect square, take it out of the radical, and we're going to leave the leftover under the radical symbol. And I will model that now. And don't forget here, I'd like you to make sure you write this over here. So you can pause now and write this. But how you break apart, right? How you break apart that radical, the radicand, what's underneath the radical sign, is by using the product rule. Okay, so pause if you need to, and here's some other information, okay? But I'm going to proceed for number 5. So if I look at root 32, I can break that apart. I know that that also means the square root of 16 times, because I'm going to think about my product rule, times the square root of 2. Okay, well, can I break apart 16 into its square root? I can. The square root of 16, that is a perfect square, is 4. And it says for number 3, leave the leftover under the radical symbol. So the answer to the square root of 32 is 4 root 2. Okay, now let's look at number 6. So when I break apart what's underneath the radical sign, or the radicand, is I want, my goal is to break this apart into factors that are, maybe one of them will be a square number. I am just going to tell you that I worked it out already. So you could always look up, you can Google, what are the factors of 180? And when you do that, you're going to find lots of factor pairs. Look for square numbers. It doesn't always have to be square numbers. Once you start factoring it, you keep factoring and factoring, you will get to its prime factorization. But I happen to know that 180 is also equal to 36 times 5. And I now see that this is a perfect square number. So that also equals 6. Okay. Root 5. 5 is not a perfect square, and there's nothing more I can do with that. Okay. Down to 7. So 7, I see this 147. Now, I Googled what are the factor pairs of 147. And that was very helpful because I found that one of its factors was 49. And I like 49 because 49 is a square number. The square root of 49, this is one of my favorites, is 7. So take the square root, and then root 3, I can't do anything with, so that's as simplified as it gets. Okay. 175. I have a feeling that 25 goes into 175. I could think about how many quarters fit into $1.75. Okay, so I'm going to find its factor. So I know that 25 goes into it 7 times. And I can multiply, I can break those apart. Take the square root of 25, which is 5, root 7. Okay. Number 9. I have 48, the square root of 48. So 48 I could break down in many different ways, but again, I really would, ideally, I'm looking for what is a square number that goes into 48. Well, I know 16 goes into 48. 16 times 3 is a good one to memorize. Now I can take the square root of 16, which is 4, and then I can find the square root of 3, right? So now I have 4 root 3. Okay. Number 10. I have 2 root 54. So I'm going to leave that 2 outside. And I'm going to break apart 54. I love 9 and I love 6. So 9 times 6 is 54. Now I can break these apart a little bit more. So 2 times, well, now I'm going to simplify root 9 into 3. So now I have 2 times 3 times root 6. Well, I can't. And again, I want to leave this outside of the radical. And think of this, whatever is a number outside the radical, think of it as like almost a coefficient that you can multiply, right? Or play around with outside the radical sign. So I can't simplify root 6 anymore. So this ends up becoming 2 times 3, which is 6 root 6. And we are done. Okay. Let's see. I think I'm going to go for it. I'm going to do this in one video. If you need to pause, take a break, get some nachos, go for it. But I am going to go over the quotient rule and the dividing radicals because that's also part of this quadratic formula. So on the next page, break apart the radicands using the quotient rule. So like I already taught this to you, but the square root of a over b also equals the square root of a. So if I'm breaking it apart over the square root of b. You're going to look for the perfect square radicals and simplify them, kind of like what we did with that other page. Simplify the radicands if you can, and simplify everything else. Let's go for it. Okay, so if I see, and you're going to see a lot of these because it's a really nice perfect square. Square root of 49 is 7 over the square root of 10. 100, forgive me, is 7/10. So that's the simplified answer. Over here, we have, well, let's see. Let's go ahead and simplify. We're going to go ahead and simplify this first. Okay, so I know that 8 is a factor of 32. So this is also going to equal the square root of 1 over 4. Okay, so I can take the square root of 1/4 because the square root of 1 is 1. Square root of 4 is 2. So the answer is 1/2. For number 3, I have 3 over 16. Let's see. Well, the square root of 3, I can write this as the square root of 3 over the square root of 16. Square root of 3, well, I know the square root of 16 is 4, so that's the answer. Number 4 is, well, 7, let's see, over 49. I could say that is still equal to the square root of 7 over the square root of 49. And now I can take the square root of 49, that's 7, and I can't really do much with that square root of 7. So I gotta leave it like that. 5. Okay, so now I have root 10 over root 45. Okay. Well, let's see. Can I break apart any of these? Let's see. So if I have the square root of 10 over 45, can I simplify any of this? Well, can I divide each by 5? This is kind of interesting. So I'm going to break this apart. I'm going to take my product rule too. And notice what I'm going to do. The root 5 times root 2 also equals root 10. I can also say root 45 equals root 5 times root 9. Well, guess what? These are going to cancel each other out because this becomes 1. Isn't that cool? Now I have root 2 over root 9. Hold on to root 2, and then root 9 becomes 3. See, it works. That's kind of cool. Okay, number 6. I have root 12 over root 36. Okay, well, I already see that root 36 is friendly because it's already a square number. But, here, I won't take too many shortcuts. Okay, so I have root 12 over root 36. Root 36 is 6. And on the top, I can break this apart as root 4 times root 3. I have root 4, which is 2, rad 3 over 6. Now check this out. Can I simplify this? Well, I can, because 2/6 is really equal to 1/3. Now this becomes root 3 over 3. Okay, number 7, root 96. And I have root 3. Okay, so let's see, how can I think about this? Well, do I have any square numbers here? 96. Could I break apart 96 into something? Or does 96, does 96 divided by 3? Well, that equals 32. Well, actually, root 96 divided by root 3 equals root 32. Now, can I break apart root 32? I can, into root 16 times root 2. And the answer, if I take a square root of 16, is 4, and I can't simplify 2 anymore. That's kind of cool. So I actually divided this out, right? It's kind of cool. Okay, number 8. I have 7 root 108, and I have the square root of 6 on the bottom. Okay, so, well, can I divide? What is 6 times 18? Maybe I can 108 divided by 6 is 18. So as long as they're both roots, I can divide them, okay? So I'm going to end up with 108 divided by root 6 is root 18. And now I'm going to keep the leftover outside, and I'm going to split my 18 up into root 9 and root 2. I like root 9 because root 9 is equal to 3. So 7 times 3, and think about it like this, times 2. 7 times 3 is 21 root 2. And that's the answer. Number 9. I have 3 root 5 over root 45. So I see that root 5 can go into root 45. So I can simplify this because 5 goes into 45 9 times. So I'm going to hold on to my 3. It's kind of like that gets simplified. And then I have root 9 on the bottom. So you're kind of forgetting about the radical signs for just a minute, but you're keeping it in radical form. So now I have 3 over root 39. So I'm going to hold on to my 3. And now I have a square root of 9, which is 3. Well, anything over itself is just 1. Number 10. 4 root 15. And I have over 3 root 27. Well, can I simplify what is in under the radical signs? I can by dividing by 3. So I'm going to rewrite this 4 rad 5 and 3. I'll hold on to that. 27 divided by 3 is rad 9. Okay. Now I can simplify the bottom. So on the top, I still have 4 rad 5. Can't really do anything else with that. And then on the bottom, I have 3 times the square root of 9 is 3. So this becomes 4 root 5 over 9. I can't simplify that anymore. 2 more, and then we're done. Okay, number 11. So I now have some, can I simplify what's underneath my, oh, I can, because I know that 16 times 3 is 48. Oh, that's going to be handy. Okay, let's do a couple things. First of all, let's simplify this. So I can divide 10 by 2 is 5. So I'm going to simplify that expression there. And I know that 48 divided by 3 is 16. Okay? That's going to equal 5 root 16. Well, 5 root 16 is equal to 5 times the square root of 16 is 4. So the answer is 20. And last but not least is number 12. So 12, let's see, I have 3/15. So I can simplify to 5. 84 and 7, well, let's see, 7 times 12 is 84. So 84 divided by 7 equals the square root of 12 on top. Okay, so I can rewrite this as root 12 over 5. I can rewrite 12. I know there's a square factor. So root 4 times root 3 over 5. And the final answer is 2, which is square root of 4, times root of 3 over 5. Hopefully you got better at rad. Say it's totally radical.